All right, so today is lesson 5.3, properties um, of operations. So in math, it's important, just like anything else, to know the properties of something, basically how something works. A good example of that is water. You guys know the properties of water, right? Water exists in three different forms, right? Like gas form or liquid form or solid form. So you understand that, like when water, for example, is in its solid form, it might be something that you can stand on, like a big block of ice, or if a lake freezes over, you can walk on it, right? That's a property of frozen water, is that it's solid, and there's enough of it, you can walk on it, right? Versus liquid water, you understand, like, hey, I can't do that because I can't walk on water. That's not something that we are able to physically do. So you don't step on it and expect to just stay on the top, right? We also know that you can't, if you have liquid water in a cup, that if you turn the cup upside down, the water will fall out, right? Because you know that it's not going to hold in there. And you don't want to get all wet, so you don't do that, right? So we know properties of things, and it helps us to make decisions. It helps us to react and act in a way that's appropriate with whatever it is, okay? The same thing in math. Like, if we understand how certain numbers work, or property or operations work, like multiplication and addition, we can use it to our advantage. We can utilize the things that are possible, and we can do other things that make more sense based on the properties. Okay, so it's really important for us to know these properties, and that way we can act and do things the right way, and we can use them to advantage. Again, if you you want to stand on, you want to make your drink cold, you're going to say, well, I know ice is cold, so I'm going to put it in there, and it's going to make the rest of my drink cold. Well, there you go, right? It's because you know the property of the ice, of the water, that is cold. Okay, so we're going to look at a few different properties right now. There's going to be a little bit of copying down here, so we're going to do things a little bit differently. We're going to kind of make like a table, sort of, in our notes. So let's see how it works out. Okay, so the first property, okay, is called the commutative. The commutative property. All right, try to say that to yourself. Commutative, commutative. Okay, with a T, not an N. Some people say commutative, but it's commutative. Okay, what this means is basically, this is where you change the order of the numbers. So the order of the numbers change, but it doesn't change the outcome. Okay, it doesn't change what the answer is. Now, all these properties we're going to share today are only dealing with adding and multiplication. Okay, so let's look at what this looks like in addition, and then let's look at what it looks like in multiplication. Okay, so for addition, when you use the commutative property, what that means is you can add in any order, as long as it's all adding. So here's a good example, okay? 1 plus 2 plus 3 is the same thing as 2 plus 3 plus 1. Is that true? Yeah, that's true, okay? You can add things in whatever order you want, as long as it's just adding, okay? The commutative property says I can move stuff around as much as I want, okay? So more simply, here's another example. You'll see it as, like, 5 plus 6 is equal to 6 plus 5. Again, the key is the order changes, okay? The order is what changes, okay? And so if the order changes, then it works. Now, notice this does not work for subtraction. Let me show you an example. You don't have to write this down, but let me show you just an example of why subtraction doesn't work here, okay? 3 minus 1, is that the same thing as 1 minus 3? No, right? One of them gives you 2, the other one gives you -2. So this does not work, okay? It only works for addition, okay? And then now we'll check with multiplication, okay? So multiplication, same thing, right? You can say that 3 times 4 is equal to 4 times 3. That is true, okay? It doesn't matter the order. And that's really important because sometimes we want to multiply things in a more useful order, okay? Let me give you a good example of why we might want to change the order. Let's say, for example, I wanted to multiply 2 times, let's say 2 times 12 times 5. Now, for me, 2 times 12, if I do an order, 2 times 12 is 24, and then 24 times 5, that's too big. I don't like that as much. So this is what I'm going to do instead. I'm going to rewrite it like this. I'm going to do 2 times 5 and then times 12. Well, why is that one better? Because 2 times 5 makes 10, and that makes things easier for me. You see that? Isn't it easier to multiply things by 10 than 24 times 5? Right? 10 times 12 to me is easier than 24 times 5. Right? Which one is easier, right? 24 times 5 or 10 times 12? Okay? So that's why we move things around. That's why the commutative property is important, because it allows you to move things around and make it easier on yourself. Okay, so again, if you change the order, it's the commutative property. Just so you could see it algebraically, this is what it looks like. So this would be a plus b is equal to b plus a. This one would be a times b is equal to b times a. That means a and b are standing in for any letters. Okay, let's move on to the next one. Now, it's really easy to get these two confused, so let's talk about this. The associative property. In the associative property, okay, the grouping or the parentheses change, okay? Parentheses. That's an E, sorry. Parentheses change. But order stays the same. Okay, so the parentheses change, but the order stays the same. Okay, so for example, what does that mean? What are we talking about here? Again, only works with adding and multiplication, right? Let's do the algebra first, actually. So this one means if you did like this, a plus b plus c is equal to a plus b plus c. Okay. Notice the order stays the same, but the parentheses change. Okay. Order stays the same, but the parentheses change. So here's an example. So you can see with numbers. Okay. So again, if I did 2 plus 3 plus 4, that's the same thing as 2 plus 3 plus 4. Is that true? Well, yeah. On this one, 5 plus 4 is 9. On this one, 2 plus 7 is also 9. So it works. Okay. So again, it doesn't matter. So the order has to stay the same, but the groupings change. Okay. The groupings change. And again, why would you want to do this? Why does this matter? Let me show you another example of why this would be important. Let's say you had something like this. Like, I don't know, we'll use big numbers to make my point. So let's say it was like 26 plus 18 plus 2. Well, to me, what's easier is if I add the 18 and the 2 together first. You guys see that? 26 plus 18, I have to like think about it and like carry it. It's not too hard, but it's like a little bit more work. Instead, I'd rather do it like this. 26 plus, because this makes 20. Makes it nice and easy. Does that make sense? Right? That's why I would change the order. Okay, or sorry, change the parentheses, change the grouping. So in the associative property, you change around the grouping in order to make that one easier. Okay. Because I don't 26 over 18, I don't know that on top of my head. This one I could do super fast. Okay, I could do 26 plus 20 really fast in my head. 26 plus 18 is a little bit harder. I need to like think about that one. Does that make sense? Okay. Multiplication, same thing. Okay. So it's just A times B times C is equal to A times B times C. So again, we can use an example here. I'll do a different color for you guys. If I did like 3 times 5 times 2, I could also do it 3 times 5 times 2. And what you'll notice is the best thing about this is you make things easier on yourself by making, if you can see a 10, okay, if you can see something that makes 10 or an even number, it's a lot easier that way, okay? All right, so that's the associative property. So how are these two different, okay? Again, the key for these two properties is, again, in commutative, the order changes, right? You actually mix up the order. In parentheses, in associative property, okay, the order does not change, but the parentheses do. All right. So that's the key. Now, can you have parentheses and have the order change? Yeah. So that would still be commutative. As if the order changes at all, it's commutative property. All right. Okay. Two more quick ones that we want to talk about. Identity properties. Let's say the original number stays the same. So in this one, like, you keep your identity, right? Like, your identity is who you are. And even if you put on a hat, you're still you. Even if you put on sunglasses, you're still you. So what can we do to a number so that it doesn't actually change? Well, what can we add to any number where nothing changes? Right? We can add 0, right? A plus 0 is still equal to A. So 5 plus 0 is still equal to 5. So even though I added something, I really didn't do anything. I didn't change anything. All right? So that's why it's called the identity property of addition, right? And for multiplication, A times 1 is equal to A, right? So 7 times 1 is still equal to 7. All right, so those are the different. So identity property is pretty simple. It's what happens. You see it and it changes the same, or it doesn't change anything. You'd be like, well, why are we doing it, Mr. Leong? You'll see later when we, especially get in chapter 6, why it's important for you to keep the identity of something. Especially with multiplication, I feel like when you multiply by 1, or we did this actually a lot when you think about it, like with fractions. In order to change a fraction to another fraction without actually changing it. So, for example, you might have said, you know, I wanted common denominator, right? So if I did like 1/2 and then I multiply by 3 over 3, remember this is 1 right here. That's 1. So that's why this is okay, because you didn't change the number. Okay. Yes, the numbers change, but it's actually the same amount, and that's what's key there. Okay. So the multiplicative identity is pretty important. Okay. Okay. Last property. Sorry, I know there's a lot. Distributive property. Um, parentheses. Sorry, you're doing the wrong letter. Okay. So with the distributive property, it's actually only multiplication. Okay, and the way the distributive property works like this: you have a number outside the parentheses, and you multiply it by all the numbers inside the parentheses. If you think about it, if you are like a mail person, you need to distribute all the mail, right? You don't just choose who gets mail. Everyone gets the mail that they're supposed to get, right? You distribute it. Or if we were in class and I said distribute these papers, it'd be distribute to everybody. Okay. So the way this looks, this isn't add or multiply. This is just like a separate property. It would look like this. A times B plus C is equal to, what you do is you multiply. So that's AB plus AC. Looks like that. So what does that look like in terms of like numbers? It would be, for example, let's say we had 3 on the outside here, and we had 2 plus 6. Okay, so normally, yes, we do PEMDAS, but just to show you that the distributive property also works, okay? What you should get here is 2 plus 6 is 8 times 3. You should get 24, right? Well, the other way you could do it is 3 times 2, plus 3 times 6. And we're going to spend a lot of time on distributive property, okay? We're going to do a lot of that later, tomorrow or Wednesday, okay? Or the next lesson. That's the next lesson, distributive, okay? But basically what you're doing is you're multiplying everything on the outside to everything on the inside, okay? Okay, so we've got these 4 properties that we went over. They're a little bit confusing, but you kind of get the hang of it if you kind of remember just really simple things about them, okay? So that's the way I kind of like to look at them, is say, okay, what about the commutative property? Well, the order changes. If I ever see the numbers change, the order, it's commutative property. Okay? Commutative order changes. Associative, if I see the parentheses shift around, but the order stays the same. Okay? So the order, if I look at the numbers, look, this one says 2, 3, 4, right? This one right here, 2, 3, 4, 2, 3, 4. But what changed was the parentheses. Okay? So this one, same order, 3, 5, 2, 3, 5, 2. But what changed was the parentheses. That's the associative. The identities, again, they just stay the same, right? And then the distributive property, we're going to spend more time on later. I just want to show you because it's going to help you for your IXL, right? So, yeah, they're not super exciting, but these properties are actually very helpful because, again, they allow us to kind of manipulate the math a little bit to make our lives easier. And we actually do it a lot of times, right? Like we like to group things together that makes sense, okay? So, for example, if you were to, let's say you had a whole bag of Skittles and you want to count them all, you'd probably sort them by like color first. And that's kind of grouping. That's like change that and then counting. Right? Well, why did we do that? It just organizes it better in a head. And that's a mix of like the associative and the commutative property just to make things easier for us. All right? Okay,